Amateur rocketry can be used in many ways in citizen science. For example, you can measure the emission spectra of the Sun. You can also detect cosmic rays and compare their results with the background radiation on Earth. Furthermore, you can use gas sensors to determine the composition of the air in different heights. Or you can build a mini telescope and observe the Milky Way during the flight. If you're more interested in biology, you can expose a petri dish with agar at the apogee and compare the bacterial growth with a petri dish that was exposed at the ground. In my case, I will launch a tiny biolab to observe microorganisms such as single-celled organisms and tardigrades during the flight. As you can see, the possibilities are endless. Since special permits and training in handling explosive substances are required for high-power amateur rockets in Germany, I will start with a cluster model rocket that can reach an altitude of about 500 meters. But more on that later. In this first episode, we will build the launch pad for the rocket. I started by making the guide rod. It consists of a stainless steel rod with a diameter of 6 mm to which I silver soldered a long nut, as it is almost impossible to cut a precisely centered thread without a metal lathe. For the feet, I used 2020 aluminum profile extrusions. There's a hole at both ends of the profile in which an M5 thread can be cut. There are numerous accessories available for these aluminum profiles, such as mounting brackets and pivot joints, both of which I have used in this project. I designed the ends of the feet to resemble a lunar or Mars lander, in order to ensure a secure standing position even on rough terrain. In order to align the guide rod and the blast deflector blade, I modified a ball joint that is normally used for camera tripods. At this point, some laser cut parts were needed. Unfortunately, I don't own a CO2 or fiber laser cutter or a CNC router, so I outsourced this task to a machining company. The two triangular shaped parts were laser cut from a 4mm aluminum blade and the blast deflection blade from 3mm stainless steel sheet. Now it was finally time to assemble everything. And here you have it, the finished rocket launch pad. In the next episode of this video series, we will build a portable ground station that can measure wind speed, wind direction, temperature, humidity and atmospheric pressure. Thanks for watching. Stay true, stay you.